So when it comes to heat and heat flow, we have three different mechanisms for doing that. We have convection, which is the circulation of fluid. So cold fluid touches a hot surface or goes through a hot region, picks up thermal energy, takes it somewhere else, dumps that thermal energy, and comes back again. So it's that cycle of scooping up and moving away heat. And this usually happens naturally because of changes in density. If your heat source is towards the bottom, the fluid down there warms up and expands, and so its density decreases. It floats up through the cooler, denser liquid around it and goes somewhere else and dissipates its thermal energy. Sometimes this isn't enough. Now, in this case, you could simply think of the radiator loop in a car or even the fluid loop, the refrigerant loop, in an air conditioning unit. And so we can cause forced convection to occur. We put a pump in place and move that fluid ourselves. Thermal conductivity usually happens when passing through a medium where it does not involve convection, right? We assume the molecules stay in roughly the same place and they pass that energy to each other through contact between the molecules, through the oscillation of one molecule hitting its neighbor and passing on energy that way. So it usually goes through a physical structure. And we mostly talk about this with solids, although the concept also applies for liquids and gases, although it's harder to test for those. So it's dependent on the cross-sectional area through which energy can be transferred, and surface area is also a factor in that. Now, most of that is due to the atomic structures and molecules resonating and bumping into each other, but there's a special kind of conductivity that's kind of like atomic scale convection. You have electrons that can pick up thermal energy and flow somewhere else. They go from the hot region to the cold region, and you can actually put two types of metal together in a junction and create a continuous current. That's called the thermoelectric effect. Although you don't really have to know that much about it. I'm pretty sure we're not going to cover it that much in the class, but it's something you're absolutely welcome to look into. It is a very, very interesting topic. And lastly, we have radiation. Now, radiation is energy in the form of light, and hot materials give off more light. That is their way of sweating off that extra energy. So you could think of it that way. There's other ways to think of it as well. But what matters here, and this is an equation that our teacher tried to show to us, is the equation for black body radiation. I'm pretty sure this is the Stefan Boltzmann equation for black body radiation. So our rate of heat transfer depends on the surface area of whatever it is we're measuring, the emissivity of the material, whatever is on the surface usually, because you can actually coat materials like a metal plate in a paint that's more or less emissive, and that'll change how efficiently it gets rid of heat. You have the vacuum permittivity constant that we've seen pop up before in other classes, and temperature to the fourth power. So as materials get hotter, they get exponentially more radiant. They let go of energy through light much more easily. And so that's why a surface can be really, really hot and not glow, but you heat it up just a little bit more and it starts to glow red, and then a little bit more and it starts getting orange hot, and then yellow hot really, really quickly. Now, Kirchhoff's law of radiation is an important thing to understand because materials can not only emit light, they can also absorb it. So Kirchhoff's law of radiation is that materials are just as emissive as they are absorbent. So a very reflective material is not very good at absorbing light, so its emissivity is really low. Materials that are really good at absorbing light, like let's say a black paint, are really good at getting rid of it as well. And so you can think of this emissivity as being like the sponginess of a material. Think of it this way. You want to clean up a puddle of water, you can use a sponge or a towel. It's really absorbent, it can soak up that water, and then you wring it back out again and a ton of water comes out, right? Something that's not very emissive is kind of like plastic wrap. You dip that in water, it gets a little bit wet, and then it's hard to get that water back off. It doesn't really do that job very well.